Okay, can you hear me?
There, I can hear you.
Oh, sorry,
Sorry.
everybody. Well, let's go back in time. I apologize. I thought I did a great job too on this first couple,
Oh, sorry for not
first
stopping you
couple
sooner. I
tries.
thought I was having the audio issues on my end. Um, so yeah, we'll back it up.
Yeah, okay. Well, let's start again. Hi, everyone. My name is Erin. I apparently don't know how to use a headset, and I'm here today to talk to you a little bit about an introduction to our webinar. So first off, thank you. Apologies again for our audio glitch. We do host these webinars, live webinars, usually without audio problems, every 2 weeks on a wide variety of technical topics. So if there is a particular topic you would like to see, or if we have audio problems, please, yeah, send those through us the chat. Thanks to everybody who typed notes about not being able to hear me. I appreciate it. If you are watching this webinar off of our YouTube channel in the future, you can just add it, request a future webinar in the comment section below, add your questions, and engage with us at any time throughout the presentation. We do monitor that question panel. Now, today's webinar, as I said a few minutes ago, but nobody heard, is focused on how to use our optimization software features for reducing subgrade construction costs. Specifically, we'll be looking at excavation, embankment, and the hauling costs associated with the construction of a road project. The agenda that I showed you that you couldn't hear me talk about, but basically I'm going to cover off a couple points here just to get us some foundational knowledge, a brief introduction to what earthwork optimization is, and the types of projects that it is suitable for. Now, not all projects are suitable for optimization. So we'll talk a little bit about some of the characteristics that make something, worthy of being optimized. Then I'm going to pass it off to our resident webinar expert, Matthew Dickey, and he is going to take us in the software to give us some workflows in terms of setting up an optimization, configuring your costing table, adding in some project constraints like min and max grade, etc. And then right through to how you can share the results of an optimization with your road contractor. Okay, so how does it work? Take two. So there are 5 key inputs to optimization. The first is a topo surface. So you can import your topo data, create a surface from a CSV file, an LAZ file, etc., or you can actually bring in an already created topo surface or DTM from another software through LandXML or through DWG, for example. From there, we create or import a prelim horizontal alignment. This can be, yes, as I mentioned, from created in our software or imported from another. Set your typical cross-section. So we do have a really flexible, easy to use cross-section editor that you can just, quickly customize it. Most things are available in there and can be updated quite quickly. Update your cost table. And this is kind of got a big asterisk next to it. So even if your costs aren't perfect, as long as the relationship between the factors is reasonable, it's going to give you some really detailed results in terms of telling you which alignment is better and some improvements. So, costing with an asterisk. And then finally, adding in your constraints and variables. So constraints can be things like min-max grades, design speed, elevation control points, etc. So let's just take a brief look at my very rudimentary example. So we start with our topo surface. We've got our ground. There is a horizontal alignment, which we obviously can't see in profile. You could start with a vertical if you wanted, and I believe Matt is going to demonstrate both options of no vertical or a vertical. And then running it through an optimization process is going to give you an optimized vertical profile that meets all of your design variables and constraints. And really where the solution becomes most beneficial, one is the time speed saved in creating that vertical, as well as all these little tiny differences between the alignments actually really add up. We see our customers save an average of, I think it's like 15 to 25% cost improvement on their subgrade construction costs versus their manually designed projects. So that's a little bit about how it works. Now, I mentioned that not all projects are suitable. So there are some characteristics that make a project certainly more suitable for earthwork optimization. So the first is the fact that you have earthworks. And we're not talking about, a little tiny bit, a reasonable amount of earthworks. The second characteristic is that it has some flexibility to move vertically and even better, horizontally. So once you have that a little bit of flexibility, it becomes really, really suitable for optimization. And then the last one is to allow the optimizer to actually do its job. It can't be overly constrained. So if you have a road project and you've got a driveway every 30 feet, it's not going to give the software a lot of room to move vertically. And that overly constrained project, not so suitable. You probably could have done it by hand because it's rather obvious. In terms of project types, it's really applicable to greenfields and realignments. It can be used, and we've got some great YouTube resources that we can actually link. So future YouTube watchers, there should be a link in your top corner on how to use it for a resurfacing project and for widening projects. And in this case, it's not so much focused on minimizing the earthworks as much as it is for that quick profile generation. So being able to quickly fit your profile to the design criteria and to your curve parameters. In terms of infrastructure types, today our webinar is going to focus on a road project. However, this software is being used for pipelines, for railways, and other corridor projects. And with that, hopefully Matt's got audio too. I'm going to pass it over to Matt. He's going to take you in the software and hopefully has some audio.
Excellent. I think I do.
You certainly do.
Find out. All right. All right, so I'll share my screen here. We'll run through an example. It is a road example. For this one, I've got my topo surface already created, and we'll jump into location to do our design. And to start, I'm going to use a preliminary alignment that has already been created. So a preliminary horizontal alignment, in this case, will come from a land XML file, but we could really easily click it in by hand to start. And we'll make some adjustments by hand once we get going with this. So with that, let's jump into it. Another just quick comment while this gets fired up. I'm going to use our version 10 today. It is in beta testing, so it's not fully released yet, but it is the reason I'm using it today is because it's a bit faster, a bit faster, and there's a few details in there that just make it easier to work with, as well as a bunch of other features that I'm not going to focus on today. So here I'm just going to click new and reference my topo surface. And I'm going to choose this land XML file with my horizontal alignment in it. And I'm just going to add in a couple backgrounds for context. So I'm going to add in my image background. And I'm going to add in a background just showing a shapefile for a property boundary. So this fictional example that we have today is for a rural subdivision road design. So it's just a single road going in off the main road. And in this fictional example, we'll put the road in first, and then the developer will subdivide lots off that. Yeah, and in this case, we have a tentative location where starting point, that's where we'd like to put our road. Now with this, I've got my default rural road cross-section template applied. And before I do my optimization, I'm going to want to make sure that my cross-section represents the cross-section of one of my alignments. So obviously, if I'm designing a 10-meter wide road and I use a cross-section that's only 5 meters wide, that's going to create some different volumes and different interactions in the ground. So we'll just come up here. I've got my default rural road. We'll check our parameters. So my width is 3.5 meter carriage way. So paved width, 3.5 meters either side. That works for me, but we could easily create a cross-section template that does really whatever we'd like it to. And if we had different templates we wanted to apply, we can hit assign by range and apply them in here. Now, let's quickly jump into the optimization. And in this case, we'll just keep it simple to start. And we're going to right-click vertical options. The optimizer is going to sample along our alignment. So if we choose all points, there's probably going to be some points that get sampled that are very close together. And all that does is it makes it take longer to solve without a lot of added value in the accuracy. So in this case, I'm going to turn off all. I'm just going to tell it to sample in 20-meter intervals. And down here, the software is being told that the alignment can be 10 meters either side of our vertical band center, which in this case is our ground line. So I'm happy with that. In this case, we'll go over to standards. I'm going to use just fast curves for now. I'll talk about other options here later. I'm going to tell it I want minimum maximum grades of 6%, and it's let's go with K values of 32 for our crest and sag. So that's minimum K values. It can be larger, but I don't want it to go any smaller than that. And in this case, it's probably only going to be like a 50-kilometer-hour road, so it's well above my design speed. But we also want something nice and smooth for the folks that will be building here to drive on. So we can click that in. At a glance here, I've got my start of the alignment where it's tying into the existing road. That's a case where I'm just going to allow it to be tighter curves right at the intersection. So for the first 150 meters, I'm going to say it can have a crest and sag curves of 11 and 12. Control points, I'm going to click add, start of alignment. So these control points are going to fix down the alignment in a certain location or certain elevation where we're using the vertical optimizer. So at the start of our alignment, station 0, I want my roadway to be at an elevation of 3.5 meters. And in this case, where we're tying onto an existing road, I'm going to tell it that I want that initial grade to be minus 1%. So that's fixed, but we can wiggle around our alignment everywhere else. We'll hit OK, and we'll click vertical optimize. We'll click process, and it's going to run through. And the first thing it's going to do is do the sampling. And we'll have a moment here while it does its thing. Once the sampling's done, it should be fairly quick to find the optimal vertical alignment, so the alignment that minimizes our costs. And then we'll back up and we'll talk about where those costs are coming from and how we can consider more in our design with the optimization. And we'll troubleshoot some, or talk about some strategies to reduce the number of iterations, telling it to optimize something that's infeasible, and discuss the results. So that's telling us that balanced alignment was found, and let's see what it gives us. Ta-da, we've got an alignment. And we'll just zoom out a bit here. We can see our mass haul diagram, so it's very close to balanced. Yeah, and if we look at what's going on, things make sense. We've got this big surplus of material off the start because we're tying in. We need that negative 1% grade to tie in, and then we've got this dip, and that material is being used to fill across that dip, and we continue on beyond there. Now, we can also see over here, we've got a total cost estimate. So what's driving the costs in our optimization is defining our ground types. We can click this cost tab. And here I've just got one subsurface material assigned along the length of my road. And it's just called overburden in this case, and I've told it that it's going to cost $12 a cubic meter to excavate material and $4 a cubic meter to place compact that material. So in this case, if this is a rural road, it may be low. My embankment cost should probably be a little higher to reflect the extra effort for compaction. But these are user definable numbers. So you can put whatever unit costs represent your expected construction costs in here, and the software is going to account for that. And not only that, this alignment is pretty straightforward, a single material, but we can add all sorts of other materials, and we can have different handling costs for each one of those materials. So if I was going through a bunch of solid rock where we need to drill and blast, obviously it's going to cost more, and you can make a material that has higher unit cost to excavate that. And you don't have to just stick with our default ground types. You can click new and add in whatever you'd like for materials and assign geotechnical and cost parameters for those. So that's our handling costs. Now, there's another side to the Earthworks equation, and that's your movement. So we account for our material movement as well. That's defined down here. So movement costs for all ground types. So that being said, our movement costs are shared amongst all materials. So once that primary excavation has taken place, to move it to where the embankment's going to be shaped and formed and packed in between the excavation and embankment, they're going to be treated the same for the movement costs. So in here, we can pop this open. So I've got free haul, overhaul, end haul. That's just representing different categories for how far you plan to move your material. So most commonly, your free haul is going to represent your short distance. So cases where you'll have free haul will be if it's it'll be your shortest material movement. So if you have a system where you're running a dozer, a scraper, and trucks, well, your free haul distance is probably going to represent what you're moving with the dozer. Scraper would be your overhaul, and end haul would be on that. But if you're going with something like a lead hoe and a large dozer for your mid movement, then it could be a smaller free haul distance and a different overhaul distance for the in between. And then beyond that, it's typically loaded and trucked. These are also user-defined values. So if you change, for example, our loading cost to 20 cents for a free haul, it's going to figure out the best breakdown for where those distances change for the different materials. And we can come over to our free haul control. If we have just a two-haul system, we can account for that in here. And with this, we can change the distance rather than just changing the unit values. I'm going to hit cancel here, and we'll just stick with our default. Yeah, and really the movement costs, there's some cost to move material no matter what, but if you aren't concerned about it, you can also just turn that off with no costs. And it speeds up the optimization a bit, and then the software is just looking at minimizing your cuts and fills. And lastly in here, now I'm not taking into account for it for this, where I've just got one material, but we can also add quality parameters for our different materials. And the software is going to look at balancing our different quality parameters for material movement for that individual type of material. So if I need a certain amount of solid rock for fill, it's not just going to get lumped in together as a common excavation. It'll be, I need this solid rock, it comes from here to go to there. So that's our costs, and that's being driven in here. By default, our costs are accounting for the subgrade construction. If we want to include surfacing costs, we absolutely can. We'll go in here to materials, so templates, materials, and then you can say, okay, my surface layer 1 should be made up of gravel, and maybe my surface layer 2 should be made up of well-graded 1-inch minus. I'm not going to do that in this case, but we will talk about another example where I've got that all added in with quite a bit of material movement complexity in there. So yeah, we've created an alignment that minimizes those costs just with a couple clicks and a few seconds of waiting. Now, that's great. We didn't have a vertical. It was a fairly straightforward alignment to optimize. What if I put in something that wasn't feasible? So if I told it I want my horizontal alignment here and gave it grade constraints, cut constraints, etc., and it just doesn't work with everything that we put in there. So I'm going to break this just for the sake of breaking it to talk about that. I'm going to do new, and I'm going to narrow up my band center. So I'm saying that we have to be 3 meters either side of ground. I'm going to tell it that I want maximum minimum grades of 4%. And it's not going to do the full calculation here. It's just calculating my cross sections from the new alignment. But we can eliminate having to come in here, click optimize vertical, and if I just optimize this, it's going to have to run through, do the sampling. So that same sampling that we just waited for. And then it's going to search for the best alignment. And it may take a while before it realizes that there is no best alignment, because no alignment fits. So we have tools that make it easier to check the feasibility of your design, more efficient to check the feasibility of your design. So in here, I can just turn on feasibility check. We've got partial here. So I'll come back and talk about what this partial is, but I'll click process and it just spits out no profile could be found. So rather than searching for that best profile in there, it just searches, can we fit one in? And no, we can't. So I know I have to either change the constraints that I've put in there or change my alignment. And another strategy is, rather than, when we started this out, I didn't have a vertical alignment in here at all. I just used the ground line as our band center. Now, instead of, I'm just going to duplicate this, new horizontal alignment, duplicate of horizontal alignment 1. So I've got a carbon copy here. I'm just going to do a couple things to kind of pretend that we start out at the same spot as we started out in the previous. And I will have a moment here shortly to address the questions that are coming in. So if I optimize this, it's the same alignment that we had, but right now I don't have really any concept for whether I'm going to adhere to those new design constraints that I've created beyond just doing that feasibility check and it spit out no. When we do our optimization, we can set our vertical band to be something different than the ground. So rather than saying 3 meters either side of our band center, we could widen that out and it's probably going to be feasible. We've got tighter grade constraints, so the cuts are going to be bigger. Or we can do a really quick rough design by hand, get a feel for what the ground's doing, if there's spots where it makes sense to move things around, and then we can optimize off that preliminary alignment. So with this, I'm just going to pull from our kind of conventional design standpoint here. We'll pull this around. So I don't want to have that big rock knob to go through. So we'll pull that around and let's pull that around. I'm just kind of watching what the ground does underneath here as we move it. And I'll click in a quick by hand alignment and make sure that it makes sense to match the design parameters that I have. So smoothing things out. And the rest looks fairly reasonable here for me. Now, before I run it through, I'm just going to look for problem areas by doing that really quick by hand design. This is not crucial, or just me being fussy. I'm going to add a curve in there as well for that new IP that I've added. So let's come up here. And again, like at this point, I'm going to use the optimizer for it. So I don't have to really worry too much about my material movement, getting the road in the right place. I'm just doing a quick click through, and I'll worry about the details after. I won't even add curves here, but we absolutely could add curves if we wanted them. So I've got a little bit of a hump there. We'll drop that down. So now I know that it's relatively close to what I want. Seems to make sense. And when we do that optimization, we could do it relative to ground, but I've got a 3 meter cut right at that location. Now, if that's the only 3 meter cut and my band's 3 meters, there might be a little spot here where we get slightly higher than that, 3.2. So that may be infeasible if we use our band as our center. Instead, we can come in here and say band based off vertical alignment 2, and away we go. And we'll do our optimization now, and I'll answer a few questions.
Excellent. Lots of questions in the chat here, Matt. I don't know if there's any particular order you want to tackle them in, or if I can, pass them to you.
No, doesn't matter to me.
Cool. Excellent. First question then, why does the loading cost change for hauling distance?
That represents just the fact that you're handling it different ways. Now, so if you were using a dozer or a scraper or a truck to move your material, the dozer to load the blade up for that movement is going to have one cost. The scraper is going to have another. It's probably similar to the dozer, but not the same. And then you're going to see something quite a bit different when you have to load the material in the truck with either a payloader or an excavator. And yeah.
Excellent. We've got two questions that I'm going to lump together. The first question, well, I should say they're both pertaining to ground types. So can you vary ground types and layer depths along the alignment? And then the second, tied to this, is can I import my ground layers as their own surfaces?
So to both of those, yes. This is another design that I'm going to talk about a little later here, but in this case, I've got my subhorizons assigned in here. So in this case, I'm telling it that I've got hard pan, 2 meters of hard pan over an additional meter of solid rock, so it's relative to the topo surface. And I've got that from station 0 to 930. Then I've got a different material for those different ranges. So if I come in here, I can click, let's overburden over gravel over fractured rock, make our depths whatever we'd like, hit OK, and then assign that to the range we'd like. I have this already set up, so I'm not going to make changes there. But with that, we can look, now I've got my different horizons showing, and I've got my different materials indicated here for those different layers. Now with that, you'll notice that these are just offsets of the topo surface, which oftentimes it's what most users use. If you have more detailed subsurface data, we can account for that as well. I don't have an example prepped for that, but I can at least show you where in the user interface we can account for it. So you need to build a tin the same way as you would for your topo surface, and you can do that in terrain. Once you've built that tin, you can click corridor, reference terrains, and add in a subsurface layer. And the interface for this is a little different in version 9, but similar. Now with that, once you've done that, if you go assign by range subhorizons, you click this. Once you have a subhorizon referenced, instead of just doing an offset, you'll also see an option to reference the surface depth instead. So then the different layers are independent of one another and they don't necessarily have to follow one another. So yes to both. And with that, I'll hold some of the other questions that came in and we'll jump back into our design. So we've ran that through, we did our optimization, and we've got an option that has a maximum grade of 4% versus the 6% we started with, but we did remove the alignment. So we've got two strategies to help reduce the time we spend on dealing with infeasible alignments. Now let's talk about some of the other stuff that we can account for when we do those designs. So in our vertical, and I skimmed through this very quickly. I'll just circle back on this. So my vertical band control is just how far either side of our band center we want to be. So the default is 10 feet or 10 project units. The wider the band, the more granularity you have in your sampling. So narrow band, you get really not much interpolation between the samples. But at some point, you're not gaining much by having a tight band and you're constraining where things can be. Standards. So here I've used curves fast. So curves fast, in this case, I'm allowing my vertical curves to be butted right up against each other. So it's going to produce the cheapest alignment while adhering to our design constraints, but we're probably, unless we're maxing out our grade constraints, we're probably not going to have tangents in between those vertical curves. And for that, we can just come in here and click variable curves and tangents. And then we can set a minimum distance. So if I want a minimum curve length of 60 and a minimum tangent length of 60, we can assign that. And then it's going to keep a minimum tangent between my curves of 60 meters. Control points. I used a control point at the start of my alignment because I have a road I want to tie into. I obviously don't want that intersection to be in a great big fill or a great big cut. So we want that location fixed. So that's the most common use for control point. The other common use is at the end of the road if you're tying in, doing a connector. And then other times you'll use it if you have something that you want to account for that isn't driven by your earthworks costs. So a common one for that would be if you have a bridge designed along your proposed alignment, at that bridge location, it's probably not earthworks that are going to govern the position of or the elevation of your road. So you can use a control point to reflect where your road has to be for the abutment. Pits. So in this case, this design balances, and I want a balanced design. But not every design does. And we can add in borrow and spoil sites to either address material deficits or address material surplus. We'll haul our material and dispose of it at a spoil site. I won't run through this here, but we'll just say add one at the start of our alignment for a borrow site. We can say that there is a dead haul distance of 2 kilometers. And I'll tell it that I want my well-graded base material to come from there. So if I included my surfacing layers in my materials and I needed a well-graded base to construct that roadway, we could account for the dead haul to bring that material in, which is pretty useful. And we can also add site prep costs into our pits as well. And they're pretty smart. It's built right into the optimization. So if you had a long road where you had multiple options to open up pits, for example, say you're using a manufactured material, there's cost to mob equipment from pit to pit. You can put in the site prep costs and it'll take into account your material movement and that cost to open the pit and make a decision whether it's cheaper to open a new pit or eat the longer haul from an old pit. Unit costs we've already talked about. Constraints are quite powerful, and this is another means to account for things that are not just driven by earthworks. So one, we're accounting for our material movement. Oftentimes there's construction operation constraints where you can't just move material in any direction. So here we could say from station X to station Y, I only want to allow material to move ahead. So that could be an end dump kind of situation where if you're going across the swamp and you can't just pioneer ahead to the other side, we can account for your direction constraint. Other things we have in here is sidecast. So sidecast would be similar to a spoil site where we're dealing with a surplus of material, but rather than hauling that away, we can allow it to sidecast up to a certain amount of material adjacent to your road without accounting for hauling it or having to construct an embankment with it. And then we have minimum fill, full bench, and minimum cut constraints. So all these relate to the alignment and will relate to kind of geotechnical considerations. So if you're building across a mountainside and you don't want fill going down forever down the hillside, you can add a full bench constraint from station X to station Y. If you're building across an overland section and you need a minimum embankment height, you can add a minimum fill height. So pretty flexible to give you what you to account for all sorts of things that you need to account for. So yeah, and with that, I'm running shy on time here, so we won't run through a more complex example, but I have a more complex example set up. So this example here, I've run it through. I've got my different materials assigned along the length of the road. The software is optimizing those different material constraints individually, accounting for the best vertical alignment to do that to minimize my costs. So we can see we have our mass haul diagram, which in this case it's showing with our boro sites, it's balancing out. Now, this isn't accounting for the fact that we can move material at the same location in multiple directions. So the mass haul diagram itself is pretty limited, and for that we've got our Opti-haul. So our Opti-haul is a whole lot more complex, and we can account for all those different things that you can't account for in our mass haul. So here we can see we've got different material going in different directions at the same location. So useful to know where our costs are coming from. Also be useful to communicate that to your builder so they have a good idea on what's expected. And yeah, for that, we could just produce the graphic. We can also hit copy to clipboard. And we can paste that over. And with this, we get a really detailed breakdown of all our different movement requirements for all our different materials. So I've got one table breaking down my hard pan movements. I've got another table breaking down my fractured rock movements, solid rock movements, well-graded base movements, and it'll even take a note of if it's coming from a pit or going to a pit. So quite flexible, quite powerful. And then lastly, let's just jump back into the other design that we started with. So we can use the Excel spreadsheet to send that off to them if they'd like it. But you need to build what you have as well. And for that, we can file save as. We can save the file in a bunch of formats other than just their DSNX file. So sharing across different softwares is a non-issue. Probably the most common file type to save for sharing with your builders is going to be your land XML, which saves your surface data. So the surface data for your road, your alignment, and all the cross sections and good stuff. So save as land XML, and then you've got a digital copy of your design. But if you wanted to go with a CSV or ASCII file, we could save as that. If you wanted to save it as a different type of line work, such as a DXF, DWG, etc., we could do that. So pretty flexible there. And then from producing a nice, pretty design, we've got our multi-plot. And I'm not going to go through and build one of these from scratch, but you can set up workbooks to create a really quick, professional looking formatted drawing. And there we are. And and in this case, I've got my window set to not be on auto. So there, we've got that. And then I've got my cross sections generated as well. So really easy to get a formatted drawing to send out as well. And the last thing that I wanted to mention. So back in this one, we didn't run through it in the design that we were doing here, but in this optimization, I used our variable curves and tangents. So here we can see that between the end of this vertical curve, there's a tangent between my next vertical curve. So that's the difference between what we've got there. And with that, I think we can tackle a few more questions. We're already a little over time, but
two questions seem kind of related. Is it possible to use different spacing intervals? This says, in particular for my reporting and data output, they were looking to use 10 meter for one particular station range and 20 meters for another.
Yep. I won't run through all of that here. We think we probably covered in another webinar, but we can pop this open. So if we want 10 and 2, I'll set my auto intervals to be 10 and 2. I'm going to hit cancel here just so it doesn't recalculate. So I've got 2 different auto interval points, and then when I've got this set up. When I've got this, so if I want to generate my cross sections in different intervals, I will set my pagination. So if I want that 0 to 400, we can do that. I'll set my point types to have just one auto interval point, and then for the, let's say 400 to 200, I'll create a new chapter, pagination 400 to 600. I could set my auto interval points to be this other one, turn those off, and yeah, then you've got your kind of different levels of granularity for different ranges of your road. So hopefully that answers your question.
Yeah, and tied to that one actually is, can you control the spacing of the stations in that Opti-haul export to the clipboard?
Let's go in here, Opti-haul options, and off your clipboard. So we've got minimum distance. So that's just kind of, both of these parameters here are going to limit noise. So if you have like 0.1 cubic meter of excavated volume, if you set a minimum volume of say 5 cubic meters, and that 0.1 gets amalgamated with an adjacent volume. Similar for minimum distance. So that is the kind of one level of answer to that. Now, the other thing is the Opti-haul is going to be driven by your sections sampled. So if you change that, that should include what you'd like. And so this is the spacing. Now you could also change it to include auto interval points, and like that you could use a tiered approach, or standard editable points is probably a little more flexible still, where you just explicitly tell it how to or which locations where you want the extra points, and you can auto generate those in certain intervals for certain ranges as well.
Excellent. Let's tackle just a couple more. It looks like, yeah, lots of questions left here. So if we are beyond the right-of-way, how do we adjust in optimization?
So if like your legal limit, so there's kind of different levels to that. One is you could create a really flexible cross section. So let's see here. And I don't have anything set up here, but we could set a cross section that adjusts to be steeper if you're over a certain depth, or to tie to a referenced feature such as a right-of-way limit. Now that's going to help keep your project within the footprint. The other thing you can do is clip your tin, so you only have surface where you're allowed to have your roadway, and that's just going to hem in where the software wants to put the road. So obviously, if you go somewhere where there's an infinite fill because it's falling off your right-of-way limits, then it's going to just avoid that because it sees it as being very expensive. And I haven't showed it today, we've run out of time, but we also have a horizontal optimizer. So if you ran the horizontal optimizer and wanted to limit where that can go, I'd clip my tin to only allow it to move around within a certain footprint.
Awesome. Last question for the seminar, and then we'll follow up, as I said, with all of those remaining ones over email. Can a design done in AutoCAD Civil 3D be optimized using this software?
Absolutely, and a lot of our clients do that. Yeah, they may have their title block or something already set up in a CAD environment. So for that, the most common format to go with is Land XML. So you can export your, if you started the design in Civil 3D, you could export your preliminary alignment out as a Land XML file, read that into location, just as I did when I started my file, and you can use that as your starting point and do the optimization. Now with that, there's two levels or two different options for how you can account for your cross-section geometry. So your assembly won't come directly over from Civil 3D, but we have I forget the proper word for it, but we have a software extension that can approximate the assembly behavior and adapt it to a cross-section template. And yeah, so that can give you what you'd like. Most users don't use that. It's pretty easy to work with our cross-section templates here. So you can usually, in a matter of seconds, set up a cross-section template to do what you have your Civil 3D assembly doing. Make sure the attachment point is the same. So in this case, I've got my center line attached to my subgrade. If I want that to be attached to my top, I'll set this to 1 to make sure they're the same. So when you go back and forth between the two, do the optimization. So again, just bring in the Land XML, do the optimization, and once the optimization is done, save as land XML, and you can save that horizontal and vertical alignment and bring that back into Civil 3D.
Okay, I did promise one last question.
Okay.
That was the last one. I kind of want to add one more. It's a great question. So if you do have to go, I know we're over time. Yeah, feel free to jump off. However, great last question here that we're going to tackle. Are the horizontal and vertical optimizations independent?
All right, so let's, we can talk about this one. And actually, I think I've done it in this, this alignment. So let's in here. So this alignment was designed by hand, and when I optimized it, I first went through and I just optimized the vertical. And let's see what we've got in here. So I've got variable curves and tangents. It's going to take a minute to think about this as it recalculates that. So I've set up my vertical optimization, and it produced something that was decent. Now, the horizontal optimizer is built on top of our vertical optimizer. So in this case, run that by hand design through, did the vertical optimization, and then I said, well, let's just run the horizontal optimizer. So let's go in here, horizontal options and optimization. And the horizontal optimizer behaves differently. So the vertical, you don't need to click a alignment in by hand to generate a vertical alignment. The horizontal alignment you do. So the horizontal works by, we've got our IPs that are already assigned. We're going to tell the software, okay, let's allow it to move all of these IPs, and maybe IP 6 and 7 are out of control point. So we'll make it so those can't be moved. And then we can tell the software, let's allow it to move up to 300 meters in the X direction and 300 meters in the Y direction, orient grid. And that's just going to give us a big box around where that horizontal IPs could be moved to. And then the software, when we tell it to do its thing, oh, and we want to turn that off. So we've got these big boxes where our IPs could be moved to. So we tell it to run. The horizontal optimizer uses the vertical constraints, and it iteratively adjusts the horizontal IP locations to find a better position for them. So it uses a search algorithm to narrow down on a better location. And in this case, it made a big difference. I went from having a cost of 1-point-something million down to just shy of 600,000. So it is a powerful tool. But I will caveat that it does take quite a while to run. So that would be a matter of letting it run for hours to get the results that I got here.
Excellent. With that, thank you all. Well, first off, for your patience with my lack of audio at the beginning of this webinar, and secondly, for joining us today. We hope you found the content useful. If you'd like to see this video again or come back and look at some of the workflow elements, we will be putting it up onto our YouTube page. Should be up there within the next 48 hours or so. And thank you. Lots more exciting webinars in the calendar. Be sure to come back again soon.
Thanks, everyone.